Right. So quantitative survey, if you're asked to do a quantitative survey, you're asked to find the actual quantity of daisies in the field. But that would be ridiculous, wouldn't it? Because you're not going to go out and count each one. So there is a method in biology of roughly estimating, roughly calculating how many daisies are on that field. Right. So this is my field, and each one of these, just looking up, each one of these squares is 1 meter. So I'm looking at the field from a high elevated view. So over here, it's not exact, but do roughly 40. I'll leave it at 40 just to make it nice and easy, right? Roughly 40 squares across there. And yeah, but I'm going to use 20. So the area, what's the area of the field in total? 40 times 20? 800 meters squared is the area of the field. Right. I'm not going to look individually at each one of these squares and find the total. So I'm going to use a thing called a quadrat, which can be 1 meter times 1 meter square. It's a metal bar, 1 meter times 1 meter square, or it can be a half meter times a half meter. But we're using 1 meter times 1 meter. So to do your quantitative survey, first of all, pick a position in the field. Get a pen, or a pencil, or marker, or a football, and kick or throw it over your head. So let's say it's a football and you kick it. It lands here. So I'm going to drop my quadrat.
It's like hula, isn't it?
Yeah, well, it's a big square. 1 meter by 1 meter. Drop my quadrat, and I'm going to count the number of daisies inside that quadrat. So just give me a number.
4.
Yeah, we'll keep the numbers small for this example, alright? So 4. Right. Then I'm going to kick my football, stand here, and kick it across the field. The ball lands there, and I place my quadrat down at that position. I count the number of daisies in that location. So let's say there's 5. Kick the ball again. So I keep repeating the steps. Put down my quadrat. Let's say 6. Kick it again to an area that I haven't been. Put down my quadrat. There may be 2 daisies there. Kick the football again. Put down my quadrat. Let's say there's 3 there. That's how I'm going to do 10 of them. 1, 2, 3, 4, 5. Kick it again. Kick it again. So how many of them? 2, 4, 6, 7, 8. Let's say there's none there. 9. And right, will somebody get a calculator? Add them all up. Or we can add them all together. Right. 2 and 3 is 5 plus 6. 11 and 4. 15 and 1. 16. 23. 28. 28. And 9. 37. And 10. 47. Alright. So I counted a total of 47. In how many squares? 10. So look, 10 squares. Here's 10 squares. 2, 3, 4, 5, 6, 7, 8, 9, 10. That area there.
It's like 4 by 3.
So there was 47 in every 10 squares. That's what I counted. Okay, so ramp it up to 800. So 800 divided by 10 is what?
82.
80. Alright? So there's 80 of these areas. So I'm going to multiply 80 times 47.
Which is 3,000.
3,760. Okay, so I've done it once. Am I going to rely on that answer? Okay, so that was my first answer. 3760. Okay, so exactly, I'm going to do it again. So I'm going to repeat. Yeah, I'm going to repeat my experiment again. And I'm going to get my average. So if I repeat it again, let's say I do it again and I put down 10 squares and I count them all up. This time I count them all up and I get 62. Right, so I do the same thing again. 800 divided by 10 is 80, multiplied by 62. You've got a calculator there? This is 16, 86, 48, 4960. So my next average is 4960. And let's say I do it again. I got, okay, 12. And I got 960. Oh. Right, what's my last step? What should I do now? Add them up and calculate the average. So add and calculate an average. So add and then divide by 3. So add them all up. 3760 plus 4960. 9680, is that what you got?
9686. 9680. Yeah, 9680.
And then to get the average, divide by 3. 3226.6. 0.66. To round it, 3227. To round it to a whole number. Alright, so am I going to get a better result if I do more?
More better.
Yeah, the more times I do it, the more accurate my result is going to be. If I only do it once, see how much those numbers have changed? 3,760, 4,960, 960. Right, so the more times I get an average, the better my answer is going to be.